Hi everyone, and welcome back to my virtual classroom. For our science discovery episode for today, we will be learning naming compounds. So let's get started. Our topic for today is naming compounds, specifically ionic and covalent compounds. When we talked about compound, it is a substance composed of two or more elements combined in a specific ratio and held together by chemical bond. When we name the following, the first thing that we have to do is identify what are ionic compounds. Ionic compounds are made up of a metal and a non-metal. Ionic compounds has an ionic bond of a metal and a non-metal. So if you have a compound containing metal and non-metal, therefore you will have an ionic compound. There are two ways of naming them. If your metal is a cation with only one possible charge, that means that the alkaline metal cations or the alkaline earth metal cations will be named first, followed by the non-metal, where we add IDE and the ending of the root name of your non-metal. However, if your metal has two or more possible charges, such as iron, manganese, we have to name that metal by specifying the charge in Roman numeral within a bracket. And of course, we have to add IDE for the non-metal name. The ionic compounds with your cations, we will have, for example, aluminum, which is with a charge of 3 positive, and let's say we have an iron, which can be charged with 2, so we place it in a parenthesis for iron, that's Fe2 plus, and of course another iron with a charge of 3, so we put a bracket between a Roman numeral 3 to identify or to specify that it's a charge of 3. So for example, we have NaCl. So if we have an NaCl, Na is a metal, which is a sodium, and chlorine is a non-metal, which is chloride when we name it as a compound. So it will become sodium chloride. However, if we have the transition metals, which is composed of two or more possible charge, we have to identify the charge of your metal. For example, FeCl3. So how do we identify the charge of your metal? What we need to do is cross over the subscript. So that means that Fe has a charge of 3 positive and Cl has a charge of negative 1. So FeC positive 3 will be iron, and then you put in Roman numeral brackets 3, and then chloride. So here are examples of ionic compounds which are polyatomic as well. Now if you have a polyatomic ions or your covalent bond in ionic species, polyatomic ions are ions that composes of two or more oxygen atoms and one atom of another element. For example, chlorate has a Cl and an oxygen together. Chloride is a Cl with an oxygen, two or more oxygen together. The ion with one more oxygen atom will be with an ending of ATE. That is why Cl will have, if you have a chlorate, it's a ClO3 minus, that's a chlorate. And a chloride will be ClO2 minus, that's an chloride. The ion with one more atom than the other will be an 8, while the ion with one less atom will be an 8. So for example, for a polyatomic ion, its name will remain as it is when it is combined with a metal. So let's say you have calcium, which is 2 plus, and PO4, which is 3 negative. You cross the charges so that you would know the compound formed. So it will be Ca3. And then you put PO4 as a bracket because it's an ion, a polyatomic ion, and place 2 as a subscript. Remember that in your compound, your ions must combine in a ratio that gives a neutral formula overall. So that means that since calcium has 2 positive times 3, plus PO4 has 3 negative, so that's 2 times 3 negative, that will be a 6 positive and a negative 6, which is 0. Therefore, when we put this together as Ca3PO42, when we name this will be calcium phosphate. Now let's try the following. Alright, so the first thing that we have to do is to identify the cut ions and anions in each of the compound, and then we combine the names for each, eliminating the word ion. So for the first one, letter A, we have an iron, so that will be iron, and you identify the charge of the iron, that is 3, so you put brackets 3, and then SO4 is a sulfate, so you have iron sulfate. Letter B, you have Al. The charge of Al is 3. However, aluminum is not one of those substances or element that is with 2 or more charges, so its name will remain as aluminum. And then OH is hydroxide. And of course, the last one will be mercury. Now, if you put back the charges, that means your mercury here has charge of positive 1. Therefore, we name it as mercury, bracket 1, oxide. Be careful not to confuse the subscript in the formula with the charge in the metal ions. So for example, if the subscript in Fe is 2, it doesn't mean that it will be iron 2. You have to cross the subscript to know the charges of each element. Now let's proceed to the second compounds, which is your covalent bonding in molecules. Covalent bonds or covalent compounds is sharing its electrons. So when we name them, the first one that will be appearing in our naming will be the first element in the formula. And then the second element that appears in the formula will change its ending to IDE. Now, the difference between ionic compounds and covalent compounds will be the use of the prefixes. The prefixes such as mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, and so on and so forth. The prefix mono is generally omitted for the first element. We do not use the word mono for the first element, even though if it is only one. For example, if we have CO, we don't name it as monocarbon, we only name it as carbon, and we only use the prefix mono for the next element, which is your oxygen. It will be monoxide. However, for ease of pronunciation, we usually eliminate the last letter of a prefix that ends in O or A when naming an oxide. So, for example, if we have N2O5, we name this as dinitrogen. Instead of penta, we use pen only. We drop the A, so it will be pentoxide, not dinitrogen pentaoxide. Alright, so it will be dinitrogen pentoxide. Now let's try the following. Alright, so for each compound, you will be naming them using the systematic nomenclature, which includes the Greek prefixes mono, di, tri, and so on. So for letter A, the first element there is a nitrogen, And since it's only one, we place nitrogen. And there are 3 of your F, so that will be trifluoride. The second one, we have 2 of our nitrogen, so that will be dinitrogen. And since we have 4 of your oxygen, we will have tetroxide. The third one, that's sulfur tetrafluoride. Sulfur, 1. Tetrafluoride means 4, so F, 4. The last one, we have tetraphosphorus, so that is, tetra means 4, so P4. And it says decasulfide, deca means 10, so S10, so P4S10. Make sure that you double check that the subscripts in the formulas match the prefixes in the compound names such as tetra or deca. I hope that you liked our Science Discovery episode for today, and if you do, please don't forget to click that subscribe button and hit that notification bell for your attendance today. And as always, as Teacher Maria would say, please do live your life to the fullest, learn something new every day, and love one another as how our God loves us. See you next episode for Science Discoveries. Bye!